Next slide, please. So I want to start with this vision of an abundant and resilient future is possible. I think when we talk about the drought and about everything we've been facing this summer, extreme weather events and whatnot, it all can sound so dire and it's all a bit exhausting. But there really is another way. With the issues that we're facing with our water, it can be the inspiration for us to get more in line with our local ecosystems, to invite more biodiversity and to use more of our local water resources and be less reliant on these far away water systems. Next slide, please. So our current regional water system is heavily reliant on imported water. About 90% of our water is taken from distant ecosystems and communities at quite a cost. So over 100 years ago, we went up to the Owens Valley, the Los Angeles Aqueduct. William Mulholland started taking water from that area. You've maybe heard the stories about the dust storms that have ended up occurring because we've sucked all that water out of that millennial old lake bed of the Owens Lake, and the public health implications from that happening. The Colorado River is the next place we started importing water from, and that has been in the news a ton recently, and we'll get to that in a second. And then the third place is the State Water Project, the Colorado River, the California Aqueduct. And that from the Sacramento San Joaquin Delta is the current water restrictions that we've all been experiencing are based on that water having less allocation, less water coming down to our region than ever before. And the other thing to point that out too is that that system uses a tremendous amount of energy to pull that heavy water down into the LA basin. All right, next slide, please. So the scene that we are in right now with climate change, and we know that we've been seeing warmer and warmer temperatures. You know, the more we burn fossil fuels like coal, oil, and natural gas, they act like a blanket that traps heat around the globe, warming the air, land, and sea. So the more we burn those emissions, the more that blanket thickens, and that has ended up in this phenomena where we're seeing less snow. Either the precipitation that does fall is more likely to come as rain, or that snowpack that we do get, you know, is melting so much quicker over these more extreme temperatures. And so you can see in May of this year, our snowpack was looking like it should have, or we would have traditionally expected it to look near the end of the summer. And so that's when these water restrictions came down and folks were really like, uh-oh, we don't have the supply to match our demand in the way we did before. So our whole water system, next slide, is designed around the slow melt of snow, like I said before. And with these warmer temperatures, you know, not only is the snowpack evaporating quicker, but that water in the soil is evaporating quicker, the vegetation, our reservoirs, right? And you can see just from 2000 to 2022, how this is from Lake Mead, how much less water is in these reservoirs. Next slide. And like I mentioned in the get-go here, the Colorado River, right? So this has been in the news a ton recently. They asked the states to figure out how to cut back on the water allocation that we get from the Colorado River. The states were unable to make that determination. And so now, next slide. Yeah, the federal government is now going to try to figure out how we're going to use less of this system, of this Colorado River. And the reason why I'm pointing this out is that right now, the current water restrictions that we're in is not about the Colorado River. That's still coming. So we're going to still need to figure out ways to tighten our belt when it comes to water use. And that is a lead up into what we're going to be talking about today. Next slide. I also just want to mention that when we talk about climate change, we talk about those hotter hots, those drier dries like we've been experiencing, but also those wetter wets. And the reason why I bring this up, this was a report that got a lot of attention about how California the risk for a mega flood has doubled, right? Remember that warmer air holds more moisture. So we're also having this whipsaw effect between very dry times, this aridification that we're moving towards, and also when we do get precipitation, it's more likely to come down all at once in these heavy rainstorms. And soil can be our friend and our tool in building resiliency to that as well. Next slide. So right now, when we look at water use for urban areas, about half of the water that we get, that's snow melt taken from these ecosystems and communities in a far off place with tons of energy cost and much consequence. A lot of it's just going to water lawns or sprinklers overspraying, and all of these less than desirable ways of managing this precious resource. So, but this is also a huge leverage point. About half of our water is being used in these wasteful ways in our outdoor landscape. There's another way to interact with our outdoor landscapes here in the region. Next slide, please. And just, you know, the dirt, as we think of often, right? We just kind of ignore the element underneath our feet, the soil, but the soil is alive. Healthy soil can do so much for us. And it is our largest and least expensive water tank, right? So I just want to also lay that scene before we get going here. And then next slide. So we're basically confronted with three scenarios at this point. We know we need to use less water in our outdoor landscapes, right? The imperative is huge. So scenario number one, right? Business as usual. We keep the old system, the snowpack, water hungry, chasing scarcer and scarcer resources, and that building the injustice around that, right? So that's just kind of continue on what we're doing. And I think everyone recognizes that is not a solution that we want to continue down. Next slide. The other thing we're seeing happening a lot is that artificial turf and rock landscapes are getting replaced when people are pulling out their water-thirsty lawns. So yes, this uses less water in scenario number two, but it can amplify problems and create new problems. With the rock yard, for instance, you know, we're facing extreme heat issues, and that's going to create a little microclimate around your house that's going to make it even hotter, right? It's going to bake that soil underneath those rocks, and that can make it harder for the water to infiltrate and raise those temperatures in your home. And then with the artificial turf, this is a plastic product. It can be an oil-heavy product. It can actually create less water infiltration and lower water quality issues, because all of that stuff, that synthetic material, can end up in our waterways. But we want to present the third option, and this is the ecosystem model, right? How do we get in line with our local ecosystem? How do we move towards that prosperity and abundance using nature-based solutions to build climate resilience with a fraction of our water investment that we're using now, and really being more mindful of our local water resources. And these pictures here and on this next slide are both from the Theodore Payne Foundation, has a garden tour every spring. And I invite folks to go check that out, because they have, you know, a dozen or so homes, or even look on their website. They have it all cataloged from years past to really get inspired on what these landscapes can look like, right? With our native plants that have evolved to live in our climate conditions, invite that food and home for our biodiversity, cool, help clean and absorb water, that slow and spread it, sink it, versus that pave it, pipe it, and pollute it model that we have been living under. Next slide. And so I am really excited to introduce Rich to you all. He is a retired US Forest Service scientist that has been collaborating with TreePeople on our soil work for the past 2+ years, and has been a leader in urban soil research and management for 3 decades. So without further ado, I would like to turn it over to Rich.
Thank you. Amanda, great job setting this all up. And thanks for giving everybody a hint of how old I am. But you're right, it's been 3 decades, so can't get away from the truth. Okay, I'm going to go and share my screen, and we'll get into it. Let's see here. I got to go to slideshow. Why is my computer not responding? Oh, there we go. You guys see that? Everybody?
Yep, you're good.
Yes.
Okay, good. All right. So I've been asked to talk about soil and how it relates to the water cycle, and also to ecosystem health, and talk a little bit about some of the things that you all can do to help the cause. And again, Amanda really laid it out very nicely. I'm going to start with what I call the big picture. I'm going to talk about the water cycle in general. And I'm going to talk about something that often when people talk about the water cycle, they kind of leave out, and that's the plant-soil continuum. And I'll explain what I mean by that in a little bit. But it's basically an ecosystem approach to all this. And I'm also going to talk a little bit about movement of water and soil, basically because that sets up the next part is on when I'll be talking about urban impacts on soil and water cycle. So you have to know a little bit about that. I'm going to talk about natural soil solutions versus gray infrastructure. And I'm going to bring up the concept of best management practices. And I'll end with rules of thumb for what you can do. And I'll give some examples of BMPs. Particularly BMPs that we've been working with in the Healthy Soils Initiative with TreePeople. So let's start with the water cycle. And it was kind of interesting. I had a difficult time finding a figure that had soil in it, which is very surprising because soil is a really important component of all this. And so we're all familiar with evaporation, precipitation, and precipitation, of course, can take on different forms. Water that doesn't go into the soil is runoff. Water that goes into the soil is considered infiltrated. And some of it's gravitational. So that means it's moving through macro pore spaces and gets to an aquifer. And eventually that gets to surface water somewhere in the landscape. But a lot of the water ends up in the soil because the soil has the capacity to store water against gravity. That's a really important concept for everybody to key in on. It's like a bank. Not only is soil a bank for nutrients, it's also a bank for water. And of course, plants take that water up because it has because they have enough time to gain access to that water, and we call that available water. And then it gets transpired into the atmosphere. Now, water that rains comes in as precipitation, lands in vegetation, and evaporates. That's why we call it evapotranspiration because vegetation intercepts a lot of water. But this idea of the soil-plant continuum is that once the water is held against gravity in the soil, it has there's the potential for trees and plants to access that water. And if you could think of a string of water, because basically it's tension, it's soil physics. I don't want to have to go into explaining that, but just think of it like a string of water that goes from the water through the root up the stem, the xylem of the stem, and through the transpired through the leaves. And that's a continuous process, a relatively continuous process, as long as the stomata are open. So we like to think of this as green water. So this water that goes through the soil to the plants and transpired, we call that green water, and it has huge impacts on climate, huge impacts. Tropical rainforests, you could see it from space, the clouds forming, condensing over a tropical rainforest and then moving down and precipitating someplace else. So that soil plant continuum is very important. We can't talk about the water cycle without bringing soil in that. And that's why I like to think of soil water as brown water. So we have green water that's going through the plants. We have brown water that's being held against gravity in the soil. And then we have blue water that moves through the soil to aquifers out to surface waters. So before I go I always like to talk a little bit about the importance of urban areas, urbanization globally. And we, whether we like it or not, Homo sapiens has become, according to the economist, Homo urbanus. And there's lots of social, economic reasons for this, but I'm going to argue there's also good ecological environmental reasons for perhaps doing this. So in terms of economic might, just 40 of the city regions are responsible for over 2/3 of the total world economy. And most of it, it's innovation, according to The Economist. So it's really important socially, but I think it's also very important ecologically. So typically, when we think about cities, people think bad things about cities because urban environments aren't very healthy for people, and so on and so forth. And in fact, we do have to input lots of resources because the population density of people that are living there, they can't sustain themselves with the local resources, so we have to import them. And of course, we create all kinds of wastes, and so we have outputs. And so when you read the literature, they call this an ecological footprint, and they say all, nasty, bad things about cities. But I would say, and so the question is, are cities bad? Well, I would say, no, they're not bad, because where are we going to put, eventually we're going to have 9 billion people on the planet within many of our lifetimes. Where are we going to put all those people? Well, we need to densely populate, they need to live in densely populated areas so we can free land up for other resources. And so I think cities are part of the solution. And so we really need to make them work. And then an example is my Italian heritage. This is my mom, Sicilian family that, came to New York City. And there were 7 people in the family. Not one of them never learned how to drive because they didn't have to. So on a per capita basis, when people are densely populated, we can actually get quite high efficiencies for energy use and emissions. And I think, and here's an example of transport emissions on a per capita basis. And unfortunately, LA's over here. And of course, we all like to see LA move down this curve. New York City is pretty far down. And that's because of public transportation and so on, and development patterns. But what about water use? And so I did some research on water use, and we find that LA is actually doing pretty well compared to some other large cities in the United States. This is the number of gallons per day per capita, 298. And you can see my New York City over on the right, which is 363, which isn't all that bad. And these are metropolitan areas. They're not just for the city. So it includes includes the burbs as well. So LA is actually doing pretty good. Although a lot of it is residential. So by packing all these people in my view, is a way for us to get around this, the population boom that we have with Homo sapiens. But obviously packing people in dense areas, there's lots of trade-offs from an ecosystem services perspective. And so there's a lot of polluting sources. We fragment habitats, and bring in impervious surfaces, we disrupt nutrient, and we're going to talk today about the water cycle, biodiversity losses, and there's all kinds of soil impacts, and there's many, but I'll discuss these later. But the point I would like to make here is that when humans started to form cities 10, 15,000 years ago, the Romans came up with a solution to these things, these issues. And it was infrastructure, and it was great infrastructure. In fact, the Romans started using cement before lots of other people did. And they created aqueducts to bring in fresh water. They created sewer systems to get rid of the excrement. When later the Industrial Revolution, cities became pretty polluted places to live in, and people like Edwin Chadwick, who was a social reformer in London, really pushed for sanitary kinds of conditions, even for people that were poor in cities. And so we came up with this concept of sanitary cities. And of course, New York City, there's an aqueduct that brings water from the Catskills into the city. And it's very good water, high quality water to drink. However, gray infrastructure, as successful as it was, right? Because, that's why we have all these people living in cities now. When it comes to sustainability, doesn't have a very good record. And in particular, it's imperfect and it degrades over time. So in the East, we're having way more decrepit situation with our infrastructure than you guys are in LA. But you know, many of the pipes that are been in the ground for over 100 years, they're all leaking, for example. It also requires an intense use of resources. Cement and steel are very energy inefficient. They really take a lot of energy to produce. And also, what we end up with is an urban landscape with lots of runoff, low infiltration, low recharge. And we have these hydrographs. And if you're not familiar with the hydrograph, the lower right, that's flow rate, okay, on the one axis and time on the other. And you can see a forest flow rate after a storm event, which the stream hardly perks up at all. But if you're in an urban landscape, you find a really big hydrograph. And I would consider that wasted water. That's water that's running over impervious surfaces. Engineers engineer it to go as fast to the nearest drain pipe, which then goes into the nearest stream. And you get this wasted water that moves downstream and ecologically causes all kinds of havoc within the stream. So we have these flashy systems as a result of this urban landscape that's dominated by gray infrastructure. But we have an alternative approach. And Amanda brought this up very nicely. We can bring back those ecosystem services, not with gray infrastructure, but with green, brown, and blue infrastructure. You're all familiar with green, which is vegetation, but we've been pushing the idea of brown infrastructure. It's kind of like the green water, brown water, and then also blue infrastructure. And these are going to result in smaller footprints. Remember that figure I showed of the inputs, outputs of a city. We're going to reduce those footprints. We're going to create healthier environments with greater resilience. And that's what we all want, because that's the only way out, in my view, of having 9 billion people on the planet. So we got to make this work, and we need to use natural solutions. So the advantage of of the green, brown, blue natural solution approach, it avoids those side effects that I talked about before, like those high peak flows. It utilizes biological processes. So and to a large degree, they're self-maintaining if you do it right. It preserves the function of pre-existing ecosystems as much as possible. So even in New York City, we had natural forest remnants that were functioning just fine. And we can make these things work in tandem, and we can also design multi-hyper-functioning systems. I'm not going to have time to go into all that. That maybe we could do another time. So what are some challenges related to brown infrastructure in an urban context and in a context of water and drought and the water cycle and so on and so forth? So the first is in urban areas, I mentioned this before, and thanks to the Romans, you know, we have lots of impervious surfaces in urban areas. And there's a reason for that, because, you know, it gets really muddy when it rains, especially if there's compacted surfaces and things like that. And so engineers, like I said before, they work very hard to get the water off the site into the drain on the shortest distance possible and into a creek somewhere or other receiving body as fast as possible. And this, of course, these impervious surfaces, they disconnect the soil from the atmosphere, so we don't have those gaseous exchanges. Water doesn't get in. And it elevates temperatures in soil. And it also reduces the amount of organic matter. And here's, and so in LA area, based on the soil survey, soil sealing is about almost 50%. Half of the landscape is impervious surface. That's a pretty high amount, but it's not as high as other cities. So that's the good news. And here you can see underneath the impervious surface, you can see the darker soil to the up from that. Well, that's because that soil there has organic inputs into it, water inputs into it. Below the impervious surface, you get nothing. And And of course, compaction is a really big issue in urban areas. Obviously through construction, the initial process, trampling. Actually, there's a lot of subsurface compaction in soils because of vibration. And if you've ever been walking down the street and a big truck comes by, you feel the ground vibrate. Well, that's settling the soil, especially if it's at field capacity, and bulk densities will go up. And there's also crusting from raindrop splash, particularly with soils that don't have vegetation cover or mulch. And so the result is the lower left, those two circles, you have an ideal soil, which with good structure, roughly half of the soil by volume is pore space. And that pore space allows air to move in air exchanges, gaseous exchanges, the surface of the soil. It's also a place where water is stored against gravity. Those are the fine pore spaces. The more coarse pore spaces are important for aeration and for gravitational water to go down to the aquifer. But when you compact the soil, you lose the structure, and so there's roughly half of the pore space remaining that you had before. And so roots don't like that. Organisms don't like that. And it's a real serious problem. And so this is a great 3D image of the impacts of soil compaction on a very fertile soil. And this was done, Keller et al. Paper. But you can visually look at the upper left soil was not compacted, and you can see those dark areas are all pore spaces. I really want to put in a pitch for soil structure. And to me, this is one of the most elegant things about soils in general. So soils will form little PEDs, we call them PEDs. You could think of them as if you grab a healthy soil in your hand and you see little chunks of soil there, they resemble cookie crumbs. Well, that's structure, and that's granular structure. What's really cool about the structure is that it has it gives you a multifunction. It's built in because between those PEDs, there are macro pore spaces. Within those PEDs are micro pore spaces. Again, the micro pore spaces are very important for holding water against gravity. And those macro pore spaces are very important for aeration and for water to get to the aquifer. So to me, it's one of the most amazing things about soil that you can think of. I can't get into why these things form. Fungi are an important component of that, for example. But it's really a sign of a healthy soil when you have really good structure like this. And it's the first thing you lose when you compact the soil. Okay, then there's this idea of lithologic discontinuities, and I know that's a fancy word. Maybe we can come up with a better one. And essentially, if you look at that photo, upper left, where they have a soil, loamy soil, then sand and loamy soil, and if you drop water on the top of that soil, the water will not break through the sand soil interface until there's enough pressure on top of it. So usually that whole part of the soil has to fill up with water before it breaks through. And there's a lot of soil physics involved with that, which I'm not going to get into. But suffice to say that when you have these sharp discontinuities between two soil types, water movement gets curtailed. And so the teacup effect on the right is something that was found in Washington, D.C. when they were they were planting trees. And there was a lithologic discontinuity, and the water just wouldn't leave the pit. And that's when they really started to realize this. And so you could see these on these monoliths, which were taken in Washington, D.C. Those are kinds of, you could see those abrupt changes there. And also on the right is a figure that shows where these lithologic discontinuities can occur. And so this prevents water movement through the soil. And also there's this idea of soil hydrophobicity. Again, this is a soil chemistry physics lecture, and I'm not going to get into. Suffice to say that things like fire and vaporize and alter organic matter, so it condenses on top of the soil surface and it makes it hydrophobic. There are lipids that are released from tree roots or plant roots. There's surface waxes, fungal hyphae, lots of different mechanisms to get hydrophobic soils. I bring this up in the urban context because in the upper right here, White and McDonald paper, that's when I was a grad student, I did the lab work for them. We discovered hydrophobic soil surfaces in forest remnants in New York City. And we hypothesized it was coming from soot from heavy truck traffic. But in Southern California, your main culprit is fire. And also the type of vegetation that you have, the chaparral, releases a lot of surface waxes and so on and so forth. So part of this is an urban phenomena, part of it is not. So when we think about an urban landscape, we can think about a continuum of conditions of urban soils in that landscape. And again, I don't have time to get into this very much. Just suffice to say that there's a lot of variability out there. There's a lot of different conditions of soil that you'll find in an urban landscape. And all on the right, we're talking about highly engineered soils and disturbed soils to the left, where you have remnant habitats in the landscape. And so soil BMPs, when we think about soil best management practices, they really need to be specific to these different conditions, these different soil conditions, these different uses that are going to take place in the landscape, and so on and so forth. So it's going to require a long list of different ways in which we can improve soils or restore soils to a previous to get ecosystem services out of them. But it really, you have to understand and know the landscape to really apply these things. So I'm going to give you one example because I don't have that much time. It's called decompaction. And this is a colleague, friend of mine, Stu Schwartz, who's at the University of Maryland, Baltimore County. And we've done some work in Baltimore region for many, many years. And he's noticed that in a lot of residential areas, there was a lot of infiltration issues in people's yards after that people moved into the homes. And it was because the developers were causing all kinds of compaction when they did the construction, and they just brought topsoil and put it over the top. So that's kind of a lithologic discontinuity, right? You're putting a nice soil over the top of a really compacted layer, so the water was having a hard time getting through. So make a long story short, he came up with this idea of suburban subsoiling. And you can see on the right, the subsoiling results are much better than when you just put topsoil over a compacted soil. This is just a good example of a BMP. And so the Chesapeake Bay region is adopting this for big development projects because they get a lot more infiltration. Obviously, this isn't something a homeowner is going to be able to do on their own. We've also been engaged with various demonstration projects thanks to the Healthy Soil Initiative. And I have to mention that Arla was a chief funder for this project, but we've also been able to scrape up funds from other areas, and also a lot of in-kind services from lots of people. This particular project was conducted by LA Compost with lots of partners. And basically, it was an idea to get more organic matter into a park soil condition. And I don't want to go into this, I don't have the time, but we got some really interesting results even within a 6-month period. And so the point here is that we have to take these various BMPs and test them in the LA region, because a lot of these BMPs were developed elsewhere. And of course, LA's got its own soil types, its own climate. And so the devil's in the details for a lot of these BMPs, and we really have to get to those details. So there's some rules of thumb what you can do, and I'll finish off. Basically, the best thing to do is protect your soil and maintain structure. And And so those, so if you're doing any kind of heavy work, if there's any kind of construction or anything like that, you try to protect as much of the soil as you can. And so you do that by maintaining plant cover. I'm not advocating for turf grass, especially in Southern California, but certainly people use that to provide cover. Natives are, of course, way better. Use mulch when you can, and not all mulch is created equal, but that would be a whole nother talk for me to talk about that. And maybe we could do that at another time. Controlling use of the site, especially when it's wet, really can save the soil, and also provide recovery time for soils as well. It's kind of like a muscle. You know, you have to give your muscle a chance to recover. And also, and so anyway, otherwise you're going to have these disasters like those photos on the right. And of course, adding organic matter, and that helps increase infiltration, and particularly increases the storage capacity of soils. So I mentioned those fine pore spaces were really important for that. Well, I forgot to mention that organic matter is as well. And so again, amendments they're not all created equal. And again, that's another talk, but certainly compost, same thing, varies in quality. Mulch lawn clippings, if you do have lawns, and in place if possible. And of course, maintaining healthy plants, because roots add lots of organic matter to the system. And know your resource, test your soil, and we can help with interpreting those results. Only add what is needed. Also look for organisms. It's an indication of a healthy soil. So a lot of people get creeped out by seeing things in their soil, but actually that means it's pretty healthy. And avoid introducing invasive plant species. Look them up first. My wife planted butterfly weed here in Maryland, and we later found out that it's it's an invasive species. I didn't even know that. It's now considered an invasive species here in Maryland. So be really careful. And finally, you know, do what you can to capture the water you can on your site, and that's why you need high infiltration rates. Cisterns work. And of course, you know, I'm just showing this because I didn't have any other slides to indicate that, but keeping the water on site is really the most important thing that you can do. And my final message is we all have the power to make cities more sustainable and resilient to climate change. And in my view, it's the only way out of our population boom mess. You can start in your own yard or community green space using urban soil BMPs, and we're going to continue doing work on those and find ways to get it out to the community so you can get those step-by-step processes to do that. And of course, in the Southwestern United States, sustainable cities will require the wise use of water and helping to keep any water that falls onto your property on your property. AstroTurf doesn't do that. A healthy permeable soil with good water storage does. And just to say that we're going to continue working on these BMPs. There's lots of them. And we're going to come up with what we're calling an ensemble of soil BMPs. You can think of it as a recipe book that's very catered to the LA region. I'm ready for questions.
Thank you so much, Rich. That was fantastic. You can, yeah, let me just add a spotlight to me. I had a question. I'm going to open up the audio and video to others so that they can start asking questions. But I had a question. We're right now trying to get everyone to update what we think of as a Southern California yard, and it's not the lawns, it's not these European grasses. And so sheet mulching is a way to kill that grass and then putting mulch down, getting the cardboard. I'm wondering, is that what that does for the soil? Is that going to make it tougher for the water to seep through?
Well, if you put cardboard on, yeah.
Okay.
But it's going to be relatively temporary because cardboard's not going to last forever. Yeah, you know, and I didn't have time to talk about this. What you can do, there are relatively inexpensive ways to test how dense your soil is. And they're, what do they call them? Penetrometers. And you can get these, I don't know if, maybe if TreePeople has any, but you know, maybe one of the things you might want to think about is getting some penetrometers. My friend Stu Schwartz, I presented his decompaction BMP that he's doing here in Maryland, and he's been advocating the penetrometer technique because to measure bulk density, it's a lot of work. And the penetrometer will give you a pretty good indication of how dense your soils are, and whether you need to do a breakup, you know, some sort of a physical way to break up the compaction. The other thing you have to figure out, though, and this is more work, is how deep is the compacted layer. So hopefully you're just dealing with, you know, something at the surface. That's relatively easy to break up, but the kinds of things that Stu found in his work in residential areas, at least out here in the East, is that compaction went pretty deep. And it's because the heavy equipment that was out there, and it'll stay that way for a very long time, even 10 years down the road, they're still finding it compacted. So the recovery is slow. And so that's why I really advocate for prevention, because once it's compacted, and if it's a deep compaction layer, it's a lot more to do that.
I wonder about so I mean, there's also critters in the ground, and they can help decompact the soil, correct? Because I know there's I had a farmer.
Earthworms.
I have a farmer friend here in Los Angeles, and one of his chickens died, and he was looking for the toughest soil because he knew that the critters would be attracted to the decomposing thing. Is that a technique to?
I see what you're saying.
Yeah, I just noticed that was.
I think most, you know, okay.
Yeah.
I'm not familiar with that.
Okay.
I can imagine it may be working. Some people introduce worms into their systems, but we have to be really careful about that because you want to work with native species. In the East here, we have an invasive species of earthworm. It's from Asia, and they call them jumping worms. That's the common, yeah. And
I don't think I care for that.
and these jumping worms are prolific forest floor eaters. And so they're wiping out the forest floor layer in our forests. Of course, has lots of ecological implications. And they're everywhere, and people freak out because when they pick them up, they start flopping around like this. And so that's why they call them jumping worms. But they are really starting to spread out in the landscape, and it was introduced through urban horticulture systems and compost. So people moving compost around that had these worms. And also people were using them for fishing. And so you'll see a lot of them on stream banks and things like that. So be careful about what you're introducing, but you can introduce, and if they have a food source, they'll usually make it.
Okay. I think we have a question from Hugh.
Hi, Hugh.
I feel like it's a talk show. Or we've got Hugh on the line.
Is he? Maybe he's.
Hugh, you can also just type your question in the chat if your audio is not working at the moment.
Okay, yeah, do the chat. That's a good idea.
Just to let everyone else here know, we have another chat with Lynn from LA Compost on, I saw some pictures of it with our urban soil farm. That was a kind of research.
Yeah. And I forgot to acknowledge Lynn. I had it on the slide. I was rushing at that point because I was running a little late.
Good.
But yeah, Lynn has done a wonderful, great job.
Unfortunately, Hugh, we can't hear you. If you want to type your question, you can answer it that way. Amazing. Mary's adding some questions from the Facebook. Trying to newly planted trees alive in SoCal, are they exempt from watering rules in Los Angeles? Yes, use a hand, it is hose watering only. We never recommend pop-up sprinklers. 30% of that water is evaporating right away.
Yeah.
So yeah, please water your trees at the drip line. You don't trees don't necessarily want the water on their bark and things like that. As homeowners, where can we go for more information on mulching before your next talk? I am in Calabasas. We have some information on mulching. We actually have some information on how to see how well your water is draining. So we've got, if you search, I think it's, so you can search water or soils on our website, treepeople.org/learn. There's whole sections on that. But Rich, if you have any suggestions on just like little tips for mulching. I know you can get mulch from free from local arborists, but
yeah, so you have to be careful with mulch too, because that's how a lot of invasive organisms get moved around. And you have to be careful of the carbon nitrogen ratio. If you're,
is there a way to tell that if you're just an amateur?
Well, if it's wood, it's going to be the carbon to nitrogen ratio is going to be pretty high. If it straw is really, really high as well. But you have to realize that when you add a high carbon nitrogen ratio to soil, it's going to bind up some of the nutrients. But if in urban areas, there's usually a lot of nitrogen around anyway, so that might be a good thing. I haven't really thought about that.
Is there a way to fix that? Is that like planting lupines as a nitrogen fixer? What?
Yeah, nitrogen fixers are a great way to do it. Yeah, absolutely.
Fantastic.
Yep.
Okay.
Yep.
Mary, did you see any other questions, or should we?
There's a Nikki Alvarado hand up.
Someone has a hint: avoid traipsing through unmulched soil in your garden after a rain. Wait a couple or a few days to avoid compaction.
Am I up?
Oh, we can hear. This is Nikki.
Yes, I unmuted myself. I transformed a flat, but with a slight slope, 10,000 square foot Bermuda grass lawn 6-7 years ago. And what I did was I rolled out from Home Depot that thick brown construction paper that they use like for walking through model homes, and overlapping it fairly good because Bermuda will find a way. And then I covered it with a local tree trimmer was doing a boulevard nearby, and I drove up and said, "Hello, what you gonna do with that?" So they dumped it in front of my fence, and it took us months before we finally moved it. So it was decomposing there for a while, but I put a 5-inch layer all over the paper to weight it down, and waited 4 months, and then just planted very small natives, very far apart, right through the paper and tree mulch. And over the next 2 years, it became beautiful. People stopped constantly. Oh, cool. But my adobe soil, you could build a house out of it. It takes a pick to make any kind of dent in it when you're trying to dig. And if you try and dig in the winter, it's so sticky, it just sticks to the shovel or whatever you're using. You have to wipe it off, be able to make another swipe. So that's the kind of soil I'm dealing with. But after the first big rain, I went out there to see if it got to the soil because I was wanting to improve the soil, and it did not. So it was a very large rain. My street doesn't have storm gutters, and there was water pouring down the street, but no longer out my driveway like it used to. And I think it's all the spaces in the tree chunks or wood chips or whatever. I think it's all the spaces just could handle the water. So it barely got to the bottom with that first rain. But now over many years, the soil is like textured at the top level with easy to dig in, but not a foot down. But anyway, and the plants are doing fine. So it was a mystery to me when I went to do this. How exactly does that work? So I wanted to let people know it's real simple.
Well, thank you for that. Thank you, Nikki. That's what we're all about. I also want to mention that having trees actually like have the leaves and everything slows the fall of rain, which I'm sure will help with percolation and getting the water soaked in. So that's another reason to plant plants that are eventually going to create the canopy coverage. You're going to get that slower fall. They're going to help the water absorb.
Good point.
Didn't know that.
Good point.
What about the mulch the city offers free? Again, this is going to be, you're going to have to ask for I would say what I've heard is ask for non-diseased. A lot of the trees that some of the trees that are being cut down are diseased, and you don't necessarily want that in your soil.
You shouldn't be selling that.
Well, it's the free mulch usually. You have to.
But they shouldn't even be giving it away.
Exactly, I know. But it's just something to note when you ask, and then also things like palms and other invasives, and sometimes their seeds end up in the mulch, and you just have to be vigilant and try to get them. These are just come with the territory of free mulch, so. Be cautious and always ask. It's always just ask where that's coming from and things like that. If we have no other questions, I just want to thank Rich for joining us today. We're definitely going to be taking you up on that to talk about hopefully mulch. And I mean,
so we've got a couple of demonstration projects. I didn't get a chance to get into them. But we'll have more results, and so we could talk even more intelligently about it, because it does vary from place to place how these things work, and so it's very exciting. We're very excited about our demonstration projects. They've been working out really well.
Fantastic. We just want to thank everyone for joining us. We will be sending you all a link with the YouTube video of this lecture talk. We are so happy that Rich was able to join us, and please join us on December 5th, which is World Soils Day, for our talk with LA Compost, with Lynn from LA Compost, about our urban soil. It was a carbon farm, and with different kind of setups, we were seeing kind of how much carbon and how well the soil did. So we're excited about that. So please join us for that.
Yeah, I was going to show a slide, but I ran in the last minute. I took it out because I was going to take too long to get through it all. So that's why I thought I mentioned her stuff, but I didn't.
So we'll have you back. We'll have you back soon.
Good. Well, she's going to talk about it. It's better that she talks about it anyway. She knows.
So, oh, Susan, you had a question?
I do. Hi, everybody. Thanks for holding this. I'm really grateful. I just retired. I live in the Fairfax area of LA. All cement everywhere. And I have a little garden, and I feel kind of guilty because I've been watering it. So I just want to know if I should just drip. That's my question. Should I just be dripping?
Versus hose?
Yeah.
I would say we love a drip system, but if you're careful with your hose, I would warn against. I hope it's like for hose, it's you don't want to expose any of the roots of the plants. So like if you think about like, you don't want to, like, I'm thinking of just like a loose hose. Usually like there's a shower setting I think you'll still get a little bit of evaporation off of that as in terms of water efficiency, but the trick is to not expose the roots. Like you don't want to, when we teach people how to water our trees, we either we either do it on a shovel or a rock or break it up with our hands to mimic the flow of to kind of mimic rain. So I would just be careful of exposing the roots in that respect. It's up to you. We love a drip system. It's really efficient and you kind of prevent a lot of the water evaporation, and you're not going to be feeding any of the random weeds that are growing. But yeah, I would say it's up to you. You're allowed to water with a hose for your trees and things like that. But I hope that answers some of your question.
I'm gonna be a dripper. That's it.
Yeah.
Okay. Do you have mulch? Is it mulched?
No, I don't.
Oh, okay. So then, yeah, take Alex's.
I can take my grass cuttings. You were saying I can use the grass cuttings instead of throwing them out.
Yeah, you can. There's a lot of nitrogen in the grass. Well, I don't know what kind of grass you have, but out here, there's a lot of nitrogen in the grass clippings.
Okay.
Great. It's 1 o'clock. I think we'll end on that. Thank you, everyone. You have a great day.
Bye-bye.
Thanks for